Good morning, my YouTube viewers. It is Crystal here, and basically what I'm doing in this video is I'm going to review the code of Kaggle's Playground Competition Season 5, Episode 11. And basically what this competition is you have to predict upon the likelihood that somebody's going to pay back a loan. And so basically what I did was I used Catboost classifier for this. And the reason why I used Catboost classifier for this is because it had a lot of categorical columns or object columns. And so in order to classify the object columns without encoding them, I decided the best thing to do would be to use Catboost classifier, because Catboost classifier is built for categorical features. So that's what we're going to do. So here we go. We've got our competition notebook. And the first thing and you can see, before I start, I'd like to say that this morning I checked my emails, and in my emails I got a bronze medal for this notebook. So that's not too bad, getting a bronze medal. And I got a 92% average accuracy, which that's not too bad, getting a 92% accuracy on your first try. So we predict on the problem statement is that we predict on the probability of paying back a loan. And then what we're going to do is we're going to import our libraries. So we're going to import NumPy as NP, which is a numeric library that creates NumPy arrays, also creates NumPy distributions, and performs numerical computations. We're going to import Pandas as PD, which is a data processing library, and it creates the data frames. We're going to import OS, which is for the operating system, so it goes into the operating system. We're going to import Catboost, which is where we're going to have the Catboost classifier, and that's the model that we're going to use. We're going to import sklearn, which is Python's machine learning library, and that gives us our machine learning functionality. We're going to import matplotlib.pyplot as PLT, which is a visualization library, and we're going to use that to plot graphs and things. We're going to import Seaborn as SNS, which is another visualization library that is used for statistical visualization. So after we've imported our libraries, what we want to do is we want to retrieve the files, and we're going to use the OS to do that. So we retrieve our files, and the three files that we retrieve are sample submission, train, and test. Now we're going to use Pandas to read the files, and then when we read the files, we're going to use pd.readcsv, and we're going to create 3 data frames, being train, test, and submit. We're going to set Pandas up so we can view all of the columns. So that's pd.setOptions brackets display.maxColumns, none. And then we're going to view train, and you can see train has the features. It's going to be 13 columns of data. The last column is going to be loan paid back, and the other columns of data, you see that we've got a lot of categorical columns, and since there's a lot of categorical columns is why or object columns, but they're in categories, which is why I decided to use Catboost. We check for null values. There's no null values. We check info, and you can see that the data frame is integers and floats. We check our test. The test is the same format as the train, except the test does not have the final column. And the reason why the test does not have a final column is because that's what we're going to predict on. There's no null values in test. In test info, it's the same format as train info, except for the fact it doesn't have the column where you predict on the loan. We have submit. So this is the format that Kaggle wants to see when we submit our work. And so loan payback is going to be a probability. We're going to drop the ID column. And the reason why we drop the ID column is because Pandas automatically indexes each row of data, so you don't need it. We're going to analyze the target by making a histogram of loan payback. And this is the target. So you see that you've got a lot of ones and not a lot of zeros. And so in this instance, what we have is a class imbalance. We're going to process the data. So we're going to identify the categorical columns. And I took out, it said with less than 10 unique values, but I took that out. It's just, it wouldn't work because one of the columns, the last column before the target, was 30 categories, and the program wouldn't work. I had a choice. I could either delete the column or remove the column, or I could remove the with less than 10 unique values. So I removed it with less than 10 unique values. So the object columns that we have that have categories in them are gender, marital status, education level, employment status, loan purpose, and grade, subgrade. And then so I plotted these categorical columns out so you can see how they're plotted out. So you can see you've got gender, you've got marital status, you've got education level, you've got employment status, you've got loan purpose, and you've got grade, subgrade. So you had, in order to get the grade, subgrade in, you had to take out the part about less than 10 unique values, which is what I did. So now what we're going to do is we're going to take our columns that have integers. And so if train call.dtype equals int, and you did have some integer columns, and then a unique value is less than 10. So let's see what we've got over here. So you had an integer with credit score. That was an integer. And then you had an integer with ID. And so the credit score was greater than 10. And since the credit score was greater than 10, we didn't have any int calls. And then since we couldn't subplot it, but I went ahead and left the code in there. And now what we do is we create subplots to display the distribution plots for numeric columns. And so that's where we're checking to see if a column is a float. And so with the columns that are the floats, you have annual income, debt to income ratio, loan amount, interest rate, loan paid back. There's no, it went into error when I tried to plot it. So I kept the code in there, but I didn't use it. So now we're going to replace other in the categorical columns because they're object columns. Because basically in the columns gender, education level, and loan purpose, you had other. But with Catboost, you can only have one other, and we had 3 others. And so Catboost wouldn't work because I had 3 others. So I replaced other in gender with other gender. I replaced other in education level with other education. And I replaced other in loan purpose with other loan. And so that would help Catboost to work. So we're going to one hot encode our categorical columns, but they're actually object columns. So we're going to be, for column and cat columns, temp equals pd.getDummies, train call as type int, train equals pd.concat, train 10. And then so train dot drop cat calls axis equals 1 in place equals true. And then so now, because there were 30 categories in the final object column, so now we've got 61 columns of data. And so you can see we can check out what the columns are in train, and it tells you what the columns are in train, because I had some problems getting Catboost to work, and so I had to find out what the problems were, and that's why I printed out what exactly the columns were. So I do the same thing with the test file. And then so basically what happens is, I actually could delete this, but the final column, this subcategory, wouldn't work. And because the final column wouldn't work, and the reason why is because it had more than 10 unique values. It had 30 unique values. So I needed to find out where this C5 was. And the C5, it says false, but when I originally did it, it said true. And I had to find out where the C5 was. And when I found out where the C5 was, I could correct the code. And then whenever I corrected the code, I was able to get the code work. So now we define the dependent and the independent values. So y equals train.pop, loan paid back. And then whenever you pop a column out of a data frame, it doesn't come back. And then so x is train and x test is test. We're going to use sklearn's train test split to split the data frame up into training and validation sets. And now we're going to use Catboost classifier to define the model. Model equals Catboost classifier, brackets loss equals cross entropy, iterations equals 1000, learning rate equals 0.1, depth equals 6, and I said verbose equals 100, and then we're going to fit the model after we've trained it. So we've trained the model, and so you can see that we've trained the model in increments of 1000, increments of 100, and then we fit the model. And then so when we fit the model, we make predictions on the validation set, and so you can see we predicted on the validation set, and we have an accuracy of 91%. And now we're going to predict on the test set. So pred equals model.predict x test. There's your pred. And then we're going to predict on the probability. Pred proba equals model.predict proba, brackets x test, comma, entry start equals 0, entry end equals 0, thread count equals -1, verbose equals none. Pred proba equals pred proba, and then that means it's all of the rows and the second column, because in Python the numbering system starts with 0. So 1 is going to be 2. And then we say pred proba so you can see what the probability is. So we're going to create a histogram of the probability of loan repayment. So this is the histogram. You've got more values gearing towards the 1 than you do 0. So we're going to prepare the submission. Submit loan paid back equals paid profile. Submit.toCSV and bracket submission.csv index equals false. Submission equals pd.readCSV submission CSV. And then you've got your submission. So this is the submission. This is what I submitted to Kaggle. And as you can see, you're going to have the probability leans more towards the 1 than it does the 0. And so whenever I submitted my work to Kaggle, I got an accuracy of 92%. And I thought, well, 92% accuracy, that's not too bad. And so I thought, well, I'm just going to leave it like it is because I'm busy doing other things. And since it was 92%, pretty good, I went ahead and kept that, and I didn't try to improve it. But, you know, you can always try other models to see if you can improve it using other models. And I did get a bronze medal out of it. So I'm not too dissatisfied with my work. So that's it for this video. If you like my video, please like, subscribe. And I look forward to making another video for you in the very near future.